All right, let's take a look at another example for proportions. So the example goes, as part of a study conducted by Pew Research, Americans View on Mobile Etiquette, people in a representative sample of 708 American adults, age 18 to 29, were asked if they thought it was okay to use a cell phone at a restaurant. The same question was asked of a representative sample of 1,029 adult Americans aged 30 to 49. The study found that 354 of the 708 people in the sample of 18 to 29-year-olds and 412 of the 1,029 people in the sample of 30 to 49-year-olds said they thought it was okay to use a cell phone in a restaurant. Which group do you believe may have the higher proportion saying it is okay? All right, so notice that in this one, we're asking people whether they think it's okay to use a cell phone at a restaurant. So that's clearly a yes, no response. Therefore, we are dealing with a qualitative variable, which indicates that we'll be using proportions in this case. The two groups are obviously the 18 to 29-year-olds and the 30 to 49-year-olds. So I'm going to go ahead and call the 18 to 29 group 1 and the 30 to 49-year-olds group 2. So this essentially gives me my two populations. Population 1 is all 18 to 29-year-olds, and population 2 is all 30 to 49-year-olds. Now, the first question it asks, which group do we believe may have a higher proportion saying it is okay? And why do you think that is? So in other words, it just says explain. So this is not a statistics question. It's more of like, what do you think is true? So we can go ahead and brainstorm here. I'm simply going to go ahead and say the older population would be less likely to say it's okay because of different, I don't know about environment, maybe expectations. Growing up. So it's well known, and that's more or less the way the generations are set up, that people in born around the same time, they have similar expectations with respect to life, experience about major world events, interaction with technology, and so forth. So if older people are less likely to say it's okay just because of them growing up, right? They did not have cell phones growing up. This is more of this novel technology for the older group than it is for the younger group. So I want to go ahead and say that just based off of that, I think younger people are more open to technology and using it in you know different ways than older generations. So let's go ahead and say that we expect 18 to 29-year olds to be more likely to say it is okay to use a cell phone at a restaurant. All right, and again, that's solely based on our life experience. So now that we've got that settled, let's go ahead and assume that we approach this problem here with the intent of performing a hypothesis test. So let's go ahead and actually perform the appropriate hypothesis test. So we've already done most of the setup when we said that 18 to 29 is going to be group 1. So that means P1 is going to be the proportion, the true proportion of 18 to 29-year-olds who say that it is okay to use a cell phone. And then we're going to go ahead and write that P2 is going to be the proportion of 30 to 49-year-olds who say it is okay. So they're going to respond with okay. Now, as soon as I've got my parameters, I can go ahead and write out the hypothesis. The hypothesis will always be the hypothesis of equality. And now let's go ahead and think about this. Which one do we believe to be higher? So which proportion here do we believe to be higher? So we've already said 18 to 29. That was group 1. So therefore, my inequality should face P1. So this is the inequality that we're looking at. Remember that this is equivalent to the hypothesis that P1 minus P2 is 0. And the alternative that P1 minus P2 will be greater than 0. All right, so we've got the parameters, we've got the hypothesis. Now let's go ahead and perform the requirements. So let's check the requirements. And for the requirements, we got to check group 1. So that's the 18 to 29-year-olds. And if you remember how this worked, you want to always summarize your sample. So for the 18 to 39, sample size was 708. Number of successes was 354. And then that way we can get our proportion. So the proportion would be x1 over n1. Throw that into a calculator and see what you get. Ooh, this one's actually just 0.5. All right, so let's go ahead and run through these checks. So SRS and independence are going to be safe to assume. And the only one that we really need to check is the shape requirement. So that's n times p times 1 minus p. Now, this is only for group 1. So I'm going to go ahead and add the subscript 1. And I don't know what P1 is. Usually I would find it from the null hypothesis, but that's not given to me here. So we're going to use the estimated P1. All right, to go ahead and substitute, here we got 708 times 0.5 times 1 minus 0.5. And if you throw that into a calculator, you just want to see if you get a number greater than 10. So go ahead and do that. And then we're going to do the same thing for the second group. So that would be the 30 to 49-year-olds. So 1,029 and for 12 of them. All right, I'll leave this part for you because it's exactly the same thing that we did above. So this will be P2. You want to throw this into a calculator. And remember, you need your point estimate for P for the shape. So we just go ahead and say SRS, independence, and finally shape. So go ahead and complete both parts. So the shape would go in here. Give me the number. We want that greater than 10. All right, so we're almost done. Let's go ahead and get our sketch going. This is proportion, so therefore my sketch will be a normal distribution. And the fact that this is a right tail test means we're going to shade the right-hand side. So this is alpha. Let's see, what significance level do we use? They didn't say. Okay, so because they didn't say, we're going to go ahead and use 0.05. And remember that this is the assumed significance level if it's not mentioned. So because it's not given, we're going to go ahead and stick with that standard of 5% being unusual. All right, now, again, we've got a nice distribution here. There's a Z distribution. So this critical value is Z sub alpha. And we can use StatCrunch. So we'll end up going to stats, calc, normal, and go ahead and fill the relevant portions of this to find the critical value of 1.645. All right, we're kind of running out of space, so let's maybe just do the test statistics part. Purple, so test stats. So that'll be two things. One, the z-stat. And two, the p-value. All right, remember that this proportion, so it's very intuitive, same thing as the previous sections. We'll go to stats, proportion stats. We're now going to two samples because we have two samples given to us, and we have a summary. Now here, be careful, sample one, make sure that you keep the same order that we've got here. So sample one, that is 708 observations out of 354. And then our second group would be the older group. So that was 1,029 out of 412. So I actually have a printout. That's how I can see it. All right, and that's pretty much it. You want to go ahead and make sure that your hypothesis test indicated here matches your paper. So P1 minus P2, definitely 0. And then make sure that your alternative has the correct alternative hypothesis. So if we go here, we see that our alternative is a greater than. So let's change that, and we are good to go. We see our z-stat and our p-value, so let's record that. And this was less than 0.0001. So it's a really, really small p-value. Obviously, the z-stat is way in that critical region. We're landing somewhere in here. So the z-stat lands somewhere in here, very far off to the right-hand side. Therefore, we're going to go ahead and reject the null. All right, let's interpret this. We'll say we have sufficient evidence at the 0.05, or we could even say at the 5% significance level, to say that we were correct over here, that the proportion of 18 to 29-year-olds who say it's okay to use a cell phone at a restaurant is greater than the proportion of 30 to 49-year-olds who say it's okay. Who say it is okay to use a cell phone at a restaurant is greater than the proportion of 30 to 49-year-olds who say it is okay to use a cell phone at a restaurant. So we were correct. That's good for us. Now, that's not all that revealing generally, because notice it doesn't say how much greater the proportion is. The hypothesis test is limited in that it just kind of says, congrats, you were correct. Proportion 2 is actually smaller than proportion 1, but it doesn't really tell you anything. So this is where you would need to use a confidence interval if you really wanted to determine that. So remember, we just changed the test that we perform, and now we have two values. So this wasn't actually asked of us, but notice how the lower limit is positive and the upper limit is also positive. So when we're talking about P1 minus P2, because this one's positive and this one's positive, the larger proportion is the one that has that same coefficient. In this case, it would be P1. So this means that P1 is larger than P2 by as little as 0.5 to as large as 0.14. So this gives you an idea of the range of the gaps in their proportions. If your confidence interval included 0, like if this one was negative and then this one was positive, then notice that the difference could be 0. And that basically says that that would support the null hypothesis that P1 minus P2 is 0. In this case, we didn't have that because we rejected the null. All right, so hopefully that summarizes everything for us. And now let's go ahead and move on to the very last example here. So now we're going to talk about sample size. So let's suppose that an educator wants to determine the difference between the proportion of males and females who have completed 4 more years of college. So obviously we see group 1 right here, P1, and then we see group 2. I always just call P1 the group that I see first. So here it's males and then it's females. Now, we can actually use this theory to find the sample size required to meet certain conditions. So for example, when I see the word within, I know that they're referring to the margin of error. So if I want to be within 2 percentage points, that essentially means that the margin of error is 2%. And 2% translates to a margin of error of 0.02. We have 90% confidence. And then notice that the educator is going to use the 1994 estimate of 27.5% male. So P1 is 0.275 and P2 is 0.231, as reported by the US Census Bureau. So let's just quickly review how to do this. It's proportion, so we'll still be going to prop stats. So it'll be prop stats. We go to 2 samples because we have 2 samples. And then we're going to go down to where it says width/sample size, because now they're asking about sample size required. You take a look at this and you remember that you need to know everything on the left, delete sample size because we don't know that, and then tell me what the width is. So I know the margin of error is 0.02. So if I double it, that's 0.04. So that is the width. And then everything else you just know from the problem. This has to be given. So my problem says I am 90% confident. Proportion 1 is 0.27. I think it's 0.275. And then proportion 2 was 0.2. I forget what it was, 0.231. All right, and there you have it. So just verify P1, P2, confidence level, and the width. Click enter, and we get our sample size. Now notice this is sample size per group. It's just the best way to get the requirements met is with similar sample sizes. So we get 2,551. So quite large. Now, what's going to happen if the educator doesn't use any prior estimates? So if there's no prior estimates, that means that we're going to ignore these estimates because these were a very long time ago. So maybe for whatever reason, we just don't think that they will be very helpful. So we might as well be safe and just use P1 as 0.5 and P2 is also 0.5. So let's summarize, or let's update our calculator here. The width was 0.04. First proportion, second proportion, and confidence level. So remember, confidence level does not change, but the proportions do. We're now using 0.5 for both. And now we get our new sample size of 3382. All right, and so that essentially wraps up every kind of possible question that you could be asked regarding 2 proportions.